the trolley X, okay, this is trolley X, and a trolley Y, Y trolley is somewhere here, are joined by stretching spring. So stretching spring is somewhere here. The trolley has twice the mass of trolley X has twice you can see the trolley X looks little heavier than trolley Y. So the reason is that it's twice in mass than Y. When the trolleys are released, okay, are released, the acceleration of X is 2, like the acceleration of X is 2 meter per second square. It's the acceleration of this one is 2 to the right. It means it is going in this direction. What is the initial acceleration of trolley Y to the left? So its acceleration would be in this direction. So it's very simple. You can apply a situation in which both have equal forces but opposite in direction. So the force, so you can say like the the force of red one and the blue one are equal. So blue one is m times a, and for red one it is also, I can say it is m1 times a1. So it would be m2 a2. So just for simplicity I am mentioning their names like this. So you can see the mass of blue one is double, so I can write it like 2 times m1 and a2, because the mass of the blue is twice the mass of the red one. So you can cancel out this. Now it states the mass of X is 2, so X is on the right side. One second. Mass of blue is 2 times mass of red one. Now we can cancel out like this. Okay, so the mass of X, which is blue, oh, is like that is done. Acceleration of blue is 2, so I can put it like this, which is a1. So acceleration of a1 is 4. So our possible answer is this one. The wheel of a moving car, okay. The wheel of a moving car is driven by engine, by the engine. The car is the wheel of a moving car is driven by the engine. The car is accelerating in the direction shown. The car is accelerating, oh, this is the direction of acceleration. Okay, the car is accelerating the okay. In which direction does the friction force acts on the wheel? Okay, actually it is the car is accelerating in this direction. If the car is accelerating in this direction, then so if we just focus on the wheel, the like the wheel would be rotating like this. I can say something, it would be rotating in anti-clockwise direction like this. So when the wheel would be rotating in anti-clockwise direction like this, then the friction force would be opposite to its direction. The wheel would be would be rotating like in anti-clockwise direction like this, like going like this. Then the ground will provide a friction which would be opposite to its motion, that would be like this. So we can simply say that the friction would be along the direction of t. The diagram shows a cyclist diagram shows a cyclist leaning over in order to cycle around a corner. Which force is necessary to maintain the motion around the car? So C is actually C is actually the force which is responsible for its responsible for its centripetal force, and the force which is like right now when the cyclist would be leaning around the corner, then there are chances that like there is a possibility that the cyclist would would go in this direction, would would fall in this direction. In order to maintain this force which would be opposite to this force, that is kind of a force would be in this direction. So there are few forces which are responsible for its for its balance. Like we know that it is moving along a circular path, then centripetal force is provided by this friction force. At the same time, you can see there is another factor which is related with movement. So this force time this perpendicular distance will create one type of movement. Then there is one force like this, and from here to here there is a like this distance, it will create anti-clockwise movement or torque in it. This will create a clockwise this force, and this perpendicular distance is responsible for clockwise torque. This force and this distance perpendicular distance is responsible for its anti-clockwise torque. So I think so the conclusion is like this force is responsible for its balance. Like clockwise, like normally we consider centripetal force and centrifugal force for an object to move along a circular path, but right now it is about its balancing position. So here is a center of mass. This point is actually center of mass of this object. So center of mass is related with the moment or torque. So this is the distance, and here is a force. Friction forces provide centripetal force. This force and this perpendicular distance will create a clockwise movement. Similarly, this force and this perpendicular distance will counter this clockwise movement in the form of anti-clockwise movement. So clockwise movement and anti-clockwise movement would be equal, and that's why object would be balanced at this point. Okay, which diagram correctly shows the addition of 4 Newton and 3 Newton? So by head to tail method, we know that if two forces are added, then the resultant of those two forces would be, like suppose this is 4 Newton force and then we added 3 Newton force, then the possibility is that by head to tail method, and then applying the Pythagoras theorem, we can possibly, like, let's see, by Pythagoras theorem we know that hypotenuse square is equal to perpendicular square plus base square. So perpendicular square is 4 square plus base square is 3 square, so it would become 16 plus 9, which is 25, which is equal to h square, hypotenuse square. So hypotenuse would be 5. So we can say this is our possible answer. Like let's consider other options as well. You can see this is a result 4 Newton force, then it is a 5 Newton force. Four Newton force, and this is 3 Newton, but this one is going in anti like a opposite direction. So actually 4 Newton plus 3 Newton then minus 5, the resultant would be 0 Newton force, because like you can see, also sorry, like 4 Newton plus 3 Newton and 5 Newton, it would actually reach to its original position back. So you can see these two forces, 4 Newton and 3 Newton, both are in opposite direction. Either we can use 4 Newton plus 5 Newton, then it would be equal to 3 Newton, then we can see the possibility like this. So this is 4 Newton, it is not added, it is subtracted, it is opposite in direction. So we can see, like, these two, by head to tail method, these two vectors are not added. Similarly, these are not added like this, these are two added, but the resultant is not according to head to tail method. So this is according to head to tail method, that's why the answer can be considered.